Hello dear students. In this video we are going to have some practice on thermochemical calculations. First let's start with heat of combustion. Combustion means burning. So if something burns, that is combustion. So for something to burn, it needs to react with oxygen, and the product will be, if you have organic substance which has carbon and hydrogen, usually this we call it organic substance, it will give you carbon dioxide and water. If you have inorganic substance, it will give you oxides, other ones, but let's focus on these organic substances. Now when it tells you to calculate the combustion of any substance, you need to first balance the equation. For example, if you have here glucose C6H12O6, this will burn. If I tell you glucose will burn, it will burn in the presence of oxygen to give you carbon dioxide plus water. Then we need to balance the equation. You'll balance the equation. Then you'll see here you have 6 and then 6. Now to burn 1 mole of glucose, we need 6 mole of oxygen. To answer such questions, you need to balance the equation. Let's start having some questions. First question says, how many moles of oxygen are needed to burn 2 moles of methane? Methane is CH4. Let's first write the equation and balance it. We have methane, which is CH4 plus oxygen. Usually you need to write the equation. Will give you carbon dioxide plus water. Now let's see here. Let's balance the equation. We have 1 mole of carbon. Here we have 1 mole of carbon. We have 4 hydrogen, and here we have 2. So we need to write here 2. I write here number 2. Now we have 4 hydrogen here, and in this side we have 4 hydrogen. Let's balance the equation. The oxygen. The oxygen here we have 2 and 2, 4. In this side we need to have 4. So I will add here 2. 2 times 2 will be 4. Now the number of oxygen is balanced in both equations. Let's see now. For every mole of methane, I need 2 moles of oxygen. The question says 2 mole of oxygen. So if I have 1 mole, I need 2 mole of oxygen. Then if I have 2 mole of methane, how many moles of oxygen I need? That will be 4 moles, and the answer will be number 4. Let's look at another question here. How many moles of oxygen are needed to burn 3 moles of acetic acid? Let's balance the equation here. Acetic acid, which is CH3COOH plus oxygen, will give us carbon dioxide and water. Let's see. Balance the equation. Here we have 2 carbon, and here we have only 1. I'll add here 2. Now here I have 2 oxygen. Before we balance the oxygen, let's balance the hydrogen. Here we have 3, and here 1, 4. And if I put here 2, that will be 2 times 2, 4. Now let's balance the oxygen. The oxygen in this side, in the product, will be 2 times 2, 4. And here I have 2. 2 and 4, that will be 6. Here in this side, I need to have 6 oxygen. Here I have 2 in the acetic acid, and here 2, so I still need 2. 2 times 2, 4 plus 2, that will be 6. Now oxygen is balanced in both sides. Now let's see here. For 1 mole of acetic acid, we need to burn it, we need 2 moles of oxygen. The question says 3 moles of acetic acid. If I have 3 moles, I will need how many moles of oxygen? That will be 6. 2 times 3 will be 6 over 1. That will still 6. So how many moles I need? I need 6. And the answer is number 4. Let's go to another question here. In this question, it says we have nitrogen, half of it, and we have oxygen plus hydrogen will give us 1 mole. 1 mole. By the way, the number of mole, let's see here. I have HNO3, I have 2CO2, I have 3, I have here 3 NaCl. The number of mole is what is in front of the molecule. Here, I don't have anything, then it is 1. I have 2, then I have here 2 moles. I have here 3, then it is 3 moles. So this is the number of mole in the equation. Now let's see here. It says I have a half mole of nitrogen plus oxygen plus hydrogen will give me 1 mole of what? It will give me 1 mole of nitric acid. 1 mole. And the heat will be negative 174. Now let's see here. 2 mole of nitrogen plus 6 moles of oxygen plus 2 moles of hydrogen will give me 4 moles of nitric acid. What is the heat? The heat is the same like this, but I will multiply it by 4 because this is the heat of 1 mole. And now I need to find the heat of 4 mole. So I'll see negative 174 times 4, that will be 696. The answer is number 1. Let's go to another question here. And the same idea here. We have hydrogen plus iodine will give me hydrogen iodide. Now the heat of this reaction is positive 103.6 kilojoule. From this reaction, the release heat when 1 mole of hydrogen iodide decompose. Now decomposition is the same heat of formation but with opposite sign. Now if the formation, now this is the equation, this equation is equation of formation. Now we need to make it equation of decomposition. And to do that, we need to reverse the equation. So I'll say 4 hydrogen iodide breaks down to give us 2 iodine plus 2 moles of hydrogen. Now the heat will be negative 103.6 kilojoule. Now this is the heat of decomposition. It was above in the equation, the original heat of formation. Now I made it heat of decomposition, which is breaking down, when something breaks down into 2 things. But this was the heat of decomposition, this one, of 4 moles of hydrogen iodide, and the question tells us when 1 mole of hydrogen. So what I will do, I will just divide this over 4, and that will give me, if I calculate it, it will be negative 25.9. The answer is number 3. Let's see here. Now let's speak about heat of formation. I just started speaking about it above. Heat of formation when a compound is formed from its constituents. Now let's see here. Magnesium plus chlorine, it will give us magnesium chloride. So this is the formation of magnesium chloride. Now how can I make it decomposition? I'll just reverse the equation. Magnesium chloride will produce magnesium plus chlorine. Now this, if it is, let's say, positive number, whatever, this will be the same number but negative. The same number, but I will put it in negative. If I have 1 mole, it will be the same, but for 1 mole, if I have in the decomposition half mole, then is going to be divided according to the number which was there in the equation. Let's look at questions here. Here it says, from the reaction, let's say, from the reaction, here we have sulfur trioxide plus water will give you sulfuric acid, and if the heat of formation of sulfur trioxide and water and sulfuric acid are respectively negative 297, negative 286, and negative 813, then the delta H of the reaction is what? Now we have rule. It says the delta H of formation equals it equals sigma H a product minus sigma H of reactant, the total of the product minus the total of the reactant. Here we have the product, which is sulfuric acid, and this is the heat of formation of sulfuric acid, negative. Okay, so I will see delta H equals the sulfuric acid, which is negative 813, minus we add the heat of formation of the reactant together, which is negative 200, 297, and negative 287. We add them together and we minus them from the heat of formation of sulfuric acid. So let's calculate this one. So negative 813 minus the heat, the total of the heat of formation of sulfur trioxide and water, which is negative 583. Now let's minus this from this number. So when we minus 813 minus negative 583, that would be negative 230, which is choice number 1, and this is the answer. Let's look at another question here. It says the question says you have C6H6 plus, which is benzene. Benzene plus oxygen will burn to give us carbon dioxide plus water. Delta H in this question is given. It is negative 3,267. So here in this question, it is given, this one, the delta H of the whole equation is given, and it needs the heat of formation of benzene, which is this one. Now, how we are going to do it? In the first equation, we minus the product from the reactant, but here we don't have the reactant, the heat of the formation of the reactant. We need to find it, so we'll just put this number. We'll apply the equation, which is delta H equals sigma H product minus sigma H reactant. In this case, this is delta H is given, so I'll say negative 3267 equals the total of this one. Okay, so I will see the heat of formation of carbon dioxide and water is. Now there is something very important and many students do not focus on it. They just add this number plus this number and they say these are the numbers of the product, but they don't notice how many moles here we have. So we have carbon dioxide 6 moles. I will say 309 3.5 times 6 plus negative 285.8 times 3. Then I will add them together and I'll get the right answer here. So if I say 6 times negative 393.5 plus 3 times negative 285.8. Now let's add them together. Then so let's say negative 3267 equals the total of these two will be negative 3 to 18.4. Let's put this here on the side and calculate it here. And that will equal positive 48.6. And the answer will be number 1. The correct answer is number 1. Let's see here. Here we have another idea. It says from the following equations. We have here 4 equations. We have the first one, hydrogen plus chlorine gas will give us 2 HCl and negative 184. And here we have propane plus carbon breaks down to give us carbon plus 4 hydrogen and positive 105. Here we have 2 moles of nitrogen. Here we have 2 moles of ammonia will break down to give us nitrogen plus hydrogen. Here we have carbon plus hydrogen will give us benzene. Let's see here. It says from the equations above, the most stable compound. Now the most stable compound. Pause the video and think about it. Many students will think that the answer is number 1, and that is not correct. Why it is not correct? Because if you notice here, it says 2 HCl. This is the heat of formation of 2 hydrochloric acid, negative 182. Yeah, it is the highest negative in this case, but it is the heat of formation of 2 moles of hydrochloric acid, and in the choices I have 1 mole of hydrochloric acid, so this is not correct. Why? Because if you divide this over 2, it will be negative 92. So it is negative 92. Now, still it is the highest negative, right? No, it's not the highest negative. Why? Because let's see the second equation. The second equation, it is heat of decomposition, not heat of formation. Now this value 105, it is the heat of decomposition of this propane. So to make it heat of formation, we need to reverse the equation. So in this case, we are going to say 2 carbon plus 4 hydrogen will give us C6H8, and the heat of formation will be negative 105 kilojoule per mole. So this is more negative than the first one, right? Now let's see if there is something more negative. Here we have ammonia, and also it is heat of decomposition, not heat of formation. So we need to make it heat of formation. So this equation, we will reverse it. We'll make the reactant product and the product's reactants. And this we will flip it. It will be negative 92, but still that will be for 2 moles. So still this, I will divide it over 2, and it will be even much more less. And it is not the highest negative. This one is okay, it will be positive. So now I'll find that the highest heat of formation, the highest negative, is the heat of formation of propane, which is answer number 2. This question number 2 is the correct answer. So you need to think about these numbers, the moles and the signs. They make very big difference in such questions and equations. I hope this was helpful for you, and until next time, ciao.